Hello, we are discussing about our project that is study the mechanical properties of aluminum copper alloys after equal channel angular pressing. Presented by Abhishek Gwal and Amit Kumar Mahato under the guidance of Mr. Kishore Kumar, an assistant professor Department of Mechanical Engineering, Phaltech Dr. RR and Dr. S at Technical University. Abstract is the use of SPD enhances certain material properties through the introduction of an ultrafine grain microstructure. The ultrafine size of the grains in the bulk materials generally leads to significantly improved properties by comparison with polycrystalline materials having conventional grain sizes of the same chemical position composition. Mm, where the sample is pressed through a die constant within a channel band through a abrupt angle, thus the various mechanical properties are improved using the process. Uh, Introduction of aluminum and copper. It is a silvery white, soft, is non-magnetic, ductile metal. Aluminum is third the most abundant element after oxygen and silicon. Uh, both are same type of both are ductile metals, aluminum and copper. Copper is a chemical element with symbol copper, Cu, and atomic number 29, and very high thermal and electrical conductivity. In properties of usage of aluminum, properties it is a strong malleable a metal element. It has low density, resistant to corrosion. It is a good conductor of heat and electricity. Uses construction of aircraft, lightweight vehicles, and ladders. Easy shaping and corrosion resistance make aluminum a good material for drink cans and roofing materials, as boilers, cookers, overhead power cables, etc. We can use properties and uses of copper. Uh, Something same. A good electrical conductor and thermal conductor, corrosion resistance, ductile, non-magnetic, easy to allay. Uses copper uses for electrical wiring. Copper is used for plumbing in houses, sometimes used for cookware. Copper mixed with zinc to make brass and with tin to make bronze. This is the process, the introduction of equal channel angular pressing ECAP. Uh, equal channel angular pressing is one of the metal forming process which large plastic strain is imposed on a bulk material in order to make ultrafine grained nanocrystalline metals and alloys. Equal channel angular pressing is a especially attractive processing technique. It is a relatively simple procedure which can be applied to fairly large blades of many materials, ranging from pure metals to precipitation, hardened, hardened alloys, intermetallic, and metal matrix composites. Die parameter, also the influences of die parameter, that is a die channel angle and channel displacement, and material properties, strength coefficient and strain hardening exponent are investigated in equal channel angular pressing with parallel channel, that is ECAP PC, we using three-dimensional 3D finite element simulation. Here it is a die. This is die. Die used in equal angular channel pressing. Here radius is 8 mm and angle it's created 120. This is a working principle of ECAP. The principle of ECAP in which there is a die which has internal channel bent through a blunt angle A and there is an additional angle B which represent the outer arc of curvature. There the two channel intersect. The sample in the form of bar or rod is machined to fit within the channel and the die is placed in some form of fuse so that the sample can be pressed through die using a plunger. So thus the ECAF process is distinguished from the conventional rolling extrusion and drawing process. In this it produces large strength and microstructural changes due to grain refinement and gives high strength materials with improved mechanical properties. Since the cross-sectional area remains unchanged, the same billets can be pressed through die repeatedly to attain expansionally high strength. And this is the ECAP working principle. this is the plunger. Sample is here. We can press by the plunger, um, and when it's come sample is band position, is stand is increases after the after this process, after the operation, sample is come out, and there have mechanical properties improved, hardness is increased, grain size, but grain size is decreases, I think. Yeah, this is the processing routes in ECAP. There are three routes: A, B, and C. Angle is different come out, and mechanical properties and defects achieved using ECAP. Here it has been demonstrated that an ultra-fine grained structure of materials processed by ECAP may lead to significantly higher strength and hardness, but to a reduction in ductility. Uh, After ECAP, it has two measuring properties and come out. There have one tensile property and another one hardness measurement. We can see by this graph, grain size increases and hardness, grain size increases or not, and hardness increases or not. Experimental materials and their microstructure after ECAP. We are using pure aluminum in this segment and in this operation. The aluminum used in investigation was an extremely coarse grain size is 5 mm, high purity 99.99, all supplied in the form of rods. So this is the aluminum uh, before use this. After this, after 8 passes and 4 passes, created this type of thermal stability and because micro hardness of the ECAP aluminum. Annealing condition, no annealing, and ECAP 4 passes route A. Grain size is 0. 0.9, micro hardness 3.7. After uh, 0. 0.5 hours, grain size increases, hardness is decreases. After 4 passes in B route, a grain size increases and hardness is decreases. Both are same situations is going on. After 168 is grain size is increases, hardness is decreases. So it is a grain size is after for 8 passes, grain size is increases and hardness is decreases. Both are in routes. Results and discussion. The processing technique used to obtain the UFG microstructure. UFG means ultra fine grain. Right, microstructure should strongly influence the key properties of the material. It was generally observed that with the increasing number of ECAP passes, a considerable amount of sub-grain boundaries was gradually transformed. This is the aluminum alloy process, the different number of ECAP passes. Conclusion. It was found that the creep resistance of pure aluminum is considerably increased in comparison with the coarse grain and unpressed state already after first ECAP pass. After the ECAP test, the grain size of the material considerably decreases and hence the mechanical properties of the aluminum increases. This ECAP process aluminum changes the various mechanical properties like increase in hardness, toughness, strength, which can be used in automotive parts and aerostructures body parts. This is the reference we are taken reference from the here. Valid producing bulk nanostructural metals and alloy by the cell. Okay. Author details. All these things. Institute of Physics of Materials, Academy of Science of the Czech Republic, Brno, Czech Republic. Thank you, sir.